In this video, we're going to go over making measurements and reading significant figures off of devices, and also then reading significant figures from measurements that have been made by someone else. So on this one, we're going to read the amount of volume that is represented, in this graduated cylinder. So the rule is that we read to the smallest division. In this case, it's by fives. So the closest we can come is somewhere between 25 and 30, and then we estimate one smaller. So one smaller than fives would be ones. So we're going to estimate that this one's like maybe 28, or you might argue it's 29, which in the bottom line is we know the 2 is right, and we know it's somewhere around 28 or 29, but we're not completely certain of that last digit. So the significant figures then are the 2, and then that estimated number of 8 or 9. Okay, and then what's the length of this nail? So same thing. We're going to read to the smallest division on the scale. Well, this is in centimeters. The little tick marks are then tenths of centimeters, which are millimeters. So we're down here, we're somewhere between 2.8 and 2.9. So we estimate one smaller division, so that would be in tenths. So I would say it's something like 2.8, and then you estimate this to be maybe 5, so 2.85 or 2.84 or 2.86. We know the 2 and the 8 are certain, and then we are uncertain a little bit about the last one, but we're pretty sure we're close. Okay, so the significant figures are those digits in a measurement that we're sure of, plus then one estimated digit that we're not quite as sure of, but we feel pretty good about it. So significant here does not mean important. It means this, that it's certain. All right, so let's take a problem here like we're going to see later in the chapter. What's the density of a 24.5 cubic centimeter piece of gold if it has a mass of 470 grams? So in this, somebody else has made the measurements, and now we're going to have to do a problem. We're going to have to do calculations with this. So we need to be able to identify how many significant figures there are in numbers like this. So in 24.5, there are 3 significant figures. These 3 digits have all been measured and they've been recorded. So there's a 2, a 4, and a 5. So we'd say there's 3 significant figures in this. And then for 470, well, the 4 and the 7 we're certain of, but the 0 indicates that we've rounded off probably. The 0 is not certain. It's all about zeros when it comes to significant figures. So in 470, there are only 2 significant figures. So what we're going to do next then in the next video is we'll look at some more examples so we can go through the rules for determining which of the digits in a number are significant.